Hey everyone. Kind of glad to see so many StarRocks enthusiasts here today. Short disclosure by me. So you see that this presentation is unbranded. So during the planning of this summit and the talk, I transitioned out of Fanatics. So today I'm going to be presenting my experience as an engineer. Um, Regardless of business domain. And let's talk a bit about StarRocks. So we're gonna start with the sort of a data at e-commerce and problems with the legacy architectures, and gonna transition to the sort of a considerations that we had as a team, then the new architecture and the results out of it. A bit about me. My name's Oleksiy. I'm a software engineer. I've been working with the StarRocks for more than 2 years by now, and yeah, that's been a interesting experience. Problem statement, right? So what we had, sort of during my work with the certain e-commerce company, the data was fragmented between the different warehouses. Some of it was on data lake. Queries, say with Athena, were super long. Certain data sets, that there were no ability to join them. Because of such fragmentation, right amplification was present. Um, the use cases that were desired by not covered, like the very fast queries, point lookups, fact-to-fact joins, and so on, uh, were not present, and that was kind of hurting the business. Along with that, of course, the costs of sort of a scattered data warehouses and data sets were not ideal, were quite high. So the whole thing was a perfect recipe for data spaghetti, as it says there. So the vision that we had, basically of the end goal, was for data to be discoverable in a single place. So there shouldn't be any data silos and so on. The completely decentralized governance and existence of a paved path for any sort of a data related analytics, BI teams, or anyone else to sort of onboard. And again, of course, the self-service architecture, where it's like the minimum effort from the team to onboard new customers, because we do know that we cannot grow the team proportional to adoption of any platform. So those are the things that we were seeing the platform, the self-service, to produce: faster queries, visualization, of course, the text to SQL with GenAI, and like the incremental data processing and stuff. So this is what we came up with after certain considerations. StarRocks is at the center of it. It pulls the data from Kafka. It could be using Iceberg on S3. Glue is used as a catalog. Superset for visualization. Bedrock here is to say that we used off the shelf for text to SQL. So what we were looking at, right? Why StarRocks? So we had a need in compute engine, because data was on S3, as I said, right? So we were looking at lake houses. Along with that, we had a use cases that needed a very fast, near real time sort of a data access. And for that, we envisioned the OLAP database to be used. So again, why StarRocks, right? StarRocks is 2-in-1, a very fast OLAP database that like supports joins, which was something that we required. It can also, using the Glue catalog, access data on S3, Hive, or Iceberg, regardless. and the feature set was quite rich, right? So especially we were impressed by the asynchronous materialized view options and query rewrites that it brought, but a bit more on that later. So foundation, right? For any platform, foundation is the key. So uh, after some considerations, not long ones, so we selected Iceberg as a data format that we're going to use for our data lake on S3. To implement that, right, to make it happen, we needed a platform framework, you name it, to pull the data from Kafka and put it on in the Iceberg, right? We end up using the batching in Spark. Streaming wasn't supported and not needed, to be honest. But couple of things that we had to do for that. So first of all, the table maintenance, right? We know this pain point with Iceberg. And the other one is basically data sort of a transformation conversion library that was using sort of a static external configuration. And I'm going to tell you more about that later. So data ingestion, right? Two main use cases, Kafka to StarRocks and the S3 to StarRocks, as I said before. And then the options that we had for that, stream load, routine load, and broker load. And again, on that a bit later. So how we approached Kafka to S3. So the first prototypes that we used were built on stream load, which is essentially the REST calls and the data transfer over REST protocol. It didn't, even though we built the prototype very fast and we were able to sort of implement our use cases, it didn't met the goal with regards to maximum sort of a load support, which we envisioned to be 100 K messages per sec. And then why it wasn't met? Because of a high resource usage. So whenever we increase the load, the CPU CPU and memory use on both front ends and back ends just grew up tremendously, and the front ends were often overwhelmed and went offline. So the final solution that we came up with to load such big sort of a streams of data, not streams, like amounts of data from Kafka into StarRocks was the routine load. So routine load uses sort of a Kafka clients on the backends to pull data from a particular topic to the specific destination table. The only drawback that it has that transformation sort of a capabilities of the routine load, those are limited. And we had a pretty complicated structure within the messages that we're sending with Kafka. So we had to build a sort of intermediary Kafka Streams application that was used to transform data. That is, by the way, where we reused the library previously built for a purpose of sort of a data transformation between source and destination. Also, the stream application was actively using batching, meaning that there is a notion of like outer array within routine load, which means that you can group events in a single message within your routine load topic from your source. This is super effective with regards to performance. So we easily handled 100K messages per second during our load tests, and we were able to run significant number of routine loads on a single cluster with a low CPU and memory footprint. Couple of things that you need to watch for are the configurations that you have with regards to running thread, polling frequency, and something else. This tool is powerful, so you need to watch for configs. And last one that I want to mention is that the routine load supports CDC with the operation flag that's going to allow you to do either insert, update, or delete. This is how the resulting project looked like. So we had an input topic, right? And then we had multiple destination topics that were table specific, because routine load can load into a single table. And as I mentioned, configuration was externalized, right? And then just to perform left to right conversion, we were pulling data from the StarRocks to get the destination table structure. So not that exciting, the how to load data from S3 to SR. So we used either external tables in case data wasn't like Parquet or ORC that allow us to create table on top of certain like location and S3, and then pull in if needed into a native table, reload it, and then the broker load, which can like read things like CSV and put it into the table as a single command. So some issues and learnings that we had during the querying and data modeling, we end up using only widely using two different table types on all that were provided by the StarRocks. So the primary key tables were used in cases where we needed updates for a particular columns. The downside of the primary key tables is the index maintenance, right? So that is taking its toll during the load, data load and inserts, right? The duplicate keys on the opposite side, right? So as the name states, that allows the key to have a multiple sort of records with the same key, but what it allows to do is to like load big amounts of data and like reload the whole partitions pretty fast, since the primary key index should not be maintained. Couple of other things, right? So you should watch your partition and tablet size. This is always important, but for StarRocks especially, if you would like extremely fast queries, you need to put it um, um, in a certain range, right, around 1 to 2 Gs. The other thing that was interesting for us was whether or not to leave the complex types like structs on the tables, or sort of make them flat with the only primitives being available and avoiding any collections. We end up actually maintaining both cases for different types of um, um, uh, queries and use cases and data volumes as well. So with big data volumes, you might need to basically unwrap your arrays and store them flatly. Otherwise, some of the queries can be much longer. Going forward, right? So asynchronous materialized views are an amazing tool. They support a thing called query rewrite. This is when certain aggregations or other transformations that you put within your AMV are part of an arbitrary query. That information could be, that query could be directed into AMV. So not to perform those transformations on the fly, but to put them from the source where those are ready. This tool should be used in a smart way, because the reloads, the source to destination partition mapping, and the frequency of reloads and other sort of parameters and configurations of the AMV is very important, since AMV reloads could be a big contributor to your sort of a compute use. I'm on the sort of a querying and analysis, right? So please go over the respective section of the StarRocks documentation. It is pretty good. And just a couple of like pro tips, right? So the partition pruning and pushing down predicate is probably the most important thing that you need to look at, and enforcing collocation on a table level through the table definition would actually make sure your joins are as effective as those could be. So what we end up with, right? What is the current state of the platform? So schema evolution that actually alters the tables and views based on the registry of our events that we're consuming from Kafka. So this is an important part. This like shifts off a lot of kind of operational duties, operational load from the team. As DBT is the super popular tool, we also providing a DBT library with some curated data sets that are present in there. So whoever is kind of proficient or prefers DBT as a tool can build some other data sets on top of that. Apache Superset runs on top of StarRocks, of course, just to provide like a all-in-one experience. So you can use it to build dashboards, create alerts, send those dashboards over email and stuff. The Cube Dev, or also known as Cube.js, is used as a semantic layer. So this is our offering for more for BI teams to build their own cubes, like using the language they prefer, just to push out all the sort of a BI legacy out. Text to SQL, as I mentioned, built on top of the sort of existing tools. Nothing too excited. And the whole thing had a huge impact on our business and helped our analysts a bit. So what are we doing today, right? So we have thousands of tables, views, and AMVs on a single cluster, petabytes of data. We get rid of the Druid, we reduce the Snowflake, saving a ton of money on it, and the dashboards could be built within minutes right now. So what are we going to do next? Of course, more why. We're looking at the Streamlit IO widgets to be powered by StarRocks. So we're going to invest drastically in the cluster automation. We are looking forward for the metadata backup feature on the StarRocks as a big part of the disaster recovery. And then the goal is the BI tools unification on their general StarRocks platform. And with that, I am done for this talk. Thank you.
All right. Thank you very much, Oleksiy. That was great. Let me just quickly share mine. All right. All right. So yeah. With that, I'm going to open up things to Q&A, like I mentioned. If there are any questions, please use the Q&A option on the right-hand side. Just click Q&A and put your question in there. If you would like to, you can also ask to join the session, and I'd be happy to add you, and you can ask in person, face-to-face. But with that said, we do have a question. How do you guys do disaster recovery now?
That is a perfect question. So since we had to actually pivot to using single AZ approach to save on the cross AZ traffic, right? The DNR is kind of a pretty important kind of thing that you can consider. But at this point, we had two main strategies. One is for when the data could be unavailable or lost. So we had data backups on S3 done periodically, and we plan to sort of uphold the other data from Kafka and the longer sort of the older data from like Iceberg on S3. So that was the general thing. With the metadata recovery, probably we could have tried do things differently. The other strategy that we were considering, but I do not think we ever kind of get close to implementing it, is just the backup cluster. The backup cluster that is scaled down and running with a sort of empty storages, and then whenever times come, we're just switching traffic, scaling up the cluster and loading all the data there. So let me go quickly. What's the scale you're using SR with? Like parallel queries QPS. Unfortunately, I'm unable to answer that question as I said, I'm representing myself in this talk. Did you use shared nothing or shared data architecture? It is shared nothing architecture. So we do use Iceberg on S3, but a big chunks of our data are actually on EBS volumes mounted to nodes. Are you using SR caching? If yes, do you see any staleness of the data when it is the Iceberg tables, and how the disk planning is done for caching data. It's an awesome question, but it is a little bit kind of more complicated than that on the surface. So if this is questioned with regards to query cache, right, which is done on top of like a native table queries, that is split into query fragments usually, and is queried by fragments with a bunch of limitations. So there are sort of questions here, but it is in memory and reloaded whenever the source tables from those queries are changed. But it's been kind of working great for us. We are pretty generous in giving the cache out. In case the Iceberg tables and so-called data cache, when you actually store the data on the mounted volume that is on an Iceberg table. In our case, it is sort of irrelevant because, let me explain, the fresh data is stored within the native tables. Only historical data we are pulling from Iceberg for performance reasons. So we actually had no issues with this cache because the data is almost unchanged. So I don't know if this is helpful for this particular question, but I'm going to go forward. What storage have you explored to reduce costs, S3 versus EBS, GCS? It is a super cool question. Some things are stored on S3, and those are kind of like a rarely accessed data or the historical data. And it is saving us a lot of money not to maintain it as a native tables. With regards to EBS, it is indeed a problem. This is one of the main contributors to the costs on AWS, and this is something that we're going to be looking, or the team's going to be looking into improving with both like reducing IOPS in certain cases and something else. And the last one I see, how do you handle with 800? Doesn't bump in CPU problem or overwhelmed of async tasks? Uh, Perfect questions. So the answer is there are issues. We have a bunch of scripts to maintain that, but we've been able to handle that more or less efficiently. The thing is, our routine loads, apart from like a limited set, are we're trying to keep them low profile with a single thread and pretty big kind of polling period working. So that's not been not been historically overwhelming our backends. But I do understand sort of the hurdle about that and the problems that could be there, especially with the number of async tasks when on top of the routine loads, you might be running a lot of asynchronous materialized views. So it could be a sort of like a whack-a-mole game in this case. But again, we haven't faced this problem specifically because of routine loads. And I think
I
we
think
are
that
at
puts us, yeah, it puts us at
time.
time,
Yeah.
unfortunately. But that's a lot of great questions. Oleksiy, again, really appreciate you sharing your story today and answering a lot of questions. I appreciate the audience jumping in with their questions, and I'll give everybody a chance now to quickly jump to the next session. But thanks again, Oleksiy. It's been fantastic.
Yeah, as Tyler said to me before, so please go to the StarRocks Slack. There's gonna be a chance for you to ask questions for the for presenters there, and I'm gonna pull the data there today, tomorrow, and try to answer all the questions. Thank you,
Sounds
folks.
good. Bye, everyone.